I should say good afternoon. I guess it's noon.
Yeah. Yeah, and if you're just joining us now, I'm just curious to see, we did a little cross promotion on the MLflow Bay Area meetup group. So I'm curious if you're joining us, if you heard about us from that group or if it was from the online group. All right, so I think we're live on YouTube. That looks good. So I just need to check LinkedIn. Hi, everyone from LinkedIn. If you're hearing us from there, just gonna check real quick. We're just getting everything set up, and we'll go ahead and get started here in just a minute or so. But if you're joining us from LinkedIn or YouTube, I'd love to hear where you're joining from. Okay.
Trying to deselect maybe the LinkedIn link.
Yes, 1 second. All right.
Okay, no worries.
Got here live on LinkedIn. Hi, everyone. Hi, Jasmine. Good afternoon to you too. Thanks for joining us. All right, cool. Well, I'm going to go ahead and get started because we have two really amazing presentations, and I don't want to take up any more space for my intro slides. So I just have a quick couple of slides that I want to share before we kick it off to Jules and our speakers, Eduardo and Daniel. So let me share my screen real quick. All right, so thanks everyone for joining us. This is our MLflow integration from Azure ML and Algorithmia. We're super excited to have our speakers here with us today. Eduardo from Microsoft and Daniel from Algorithmia as well. And just a quick call out to our data and AI meetup group. If you're joining us on YouTube and LinkedIn, I'll send I'll Slack the link to everyone there, but I'd love for you to join us. We have a lot of cool upcoming sessions, and that's where you can get all the details of what we have coming up. We have a variety of different kind of tech talks and different sessions. We run data collab labs where it's more kind of collaborative working sessions live. And then we have all of our videos recorded, and those are on our YouTube channel. So I invite you to check out our YouTube channel and subscribe, so you'll get notified when we have new videos that we upload, and also all of our online meetups are recorded there. So I'll drop the link to those playlists. And then follow us on LinkedIn. Hi, everyone, if you're joining us from LinkedIn too. So I wanted to do a quick call out. Our next event is coming up next Tuesday, and that's another MLflow integration, this time with PyCarrot and PyTorch. So we have two awesome speakers, Moez and Geeta. So I invite you to check out our meetup page and RSVP and get all those details for that talk that's coming up next week, next Tuesday. And then I hope everyone is excited. We have our Data and AI Summit 2021 coming up at the end of May. 5 days, over 200 sessions. I don't know how they do it, but it's really awesome. Tons of amazing content. Keep up with the latest advances in open source technologies like Apache Spark and Delta Lake, MLflow, of course, and koalas. And again, we have some really, really awesome keynote speakers that I'm excited about. We have Matei, Sol, Renault, Malala this year. So I invite you to register. Registration is free, and I hope you'll join us. And with that, I'm going to pass it over to my co-host and my teammate, Jules. Take it away.
Well, hello, everyone. Welcome to our series of MLflow meetup integration. This is the first one, and I want to welcome to all of you, wherever you are, whatever time zone you are. Thanks a lot for coming. And just to set the context for both Eduardo and Daniel, I will have a couple of slides that I want to share with you in terms of, what's actually happening in the MLflow community. So let me just share this with you here for a minute. All right, let me see if I can bring up my slides. Okay, can you guys see my slides? Everything good? Lovely. Well, again, what I wanted to do was just share with you why we're actually doing this integrations and community meetup.
I think we just lost Jules. Let me just lock him real quick. All right, I just locked him. Now everyone knows we're live. Okay, I see him coming. I see him back up. Hey, Jules. Okay, now I
Unmute myself.
There you go.
Can you hear me now?
Yes,
Okay,
I can hear
brilliant.
you.
Okay, so let me go start rewind again. Well, one of the reasons why we actually want to do this is to set the context for how the integrations have evolved over the period of years and how community contributions have really moved MLflow forward in the last couple of years. And today you're going to hear from two major contributions from Microsoft Azure ML as well as Algorithmia. And these are some of the integrations.
I think, Jules, I think we lost you again. And I'm not seeing the slides. So I'm happy if you have them. I can pull them up on my screen while you present. Oh, we lost them again. Maybe third time's the charm. Thanks everyone for being patient while we try to get him back. All right, now you're muted.
I don't know. I'm getting muted. It's muting me.
Okay, you're not muted now.
Okay. And you can see the screen now.
I can't see your screen yet.
And you can see the screen.
No, I just see your video.
You can or you can't.
I cannot see your screen. If you want to share the slides with me, I can present them while you speak. Maybe that would work.
Okay, let me see if, how about now? Can you see it?
Yes, I can see. It says Jules has started screen sharing. So maybe we can have, Jules, maybe we can have you turn your camera off, and maybe that would help.
Okay.
I just see it, so it just says it's black. I don't see the slides yet. There we go. I see the slides.
But now. Yeah, brilliant. All right. So these are the set of commits and contributions that I have over the last couple of years, and we can see that is actually growing quite a bit. And if you look at some of the statistics in terms of number of downloads, that actually it's quite a bit. And so interested to start joining the community, please go to MLflow. Join a Slack channel, join a public user group, and start discussing things. And I normally manage that and answer all the questions that you have. Who is going to be our first speaker? He's from Microsoft, and he has contributed quite a bit to Azure ML, and also his thin client. So Eduardo, take it away.
Hello. All right. So so I'm on the AzureML team as a software engineer, and I'll be giving you a little bit of context on where our integration is at this point, as well as some of the current work that we're doing to allow AzureML to showcase this MLflow integration in more environments. Can you see my screen? You should be seeing a slide with AzureML's MLflow integration update.
Yep. Yes, I can see it. Perfect. Looks good.
So to start off, I'd like to thank Corey, Haru, and Paul from the Databricks team, as well as my manager, AK, from Microsoft. They've been a tremendous help across all of the integrations we've done with MLflow, as well as a lot of what we've built within AzureML. To give a little bit of context on the talk, first I'm going to introduce AzureML, since some of the audience may or may not be familiar with it, and how it relates with MLflow in terms of a lot of the integration points and why they were so easy to do. Some of the progress we've made around tracking, model registry projects, as well as AzureML deployments, and then introduce the Skinny client and how that is helping us bridge the gap between some of our more environments that our customers use, since we don't really know what the customers are using our code for, and MLflow, given MLflow brings so much with it. It's sometimes hard to merge environments with MLflow. But in our case, with this mlflow-skinny update, it should be a lot easier for more integrations coming forward. So with that, I wanted to kind of jump into AzureML. So AzureML has quite a lot of breadth amongst offerings. So the idea here is AzureML is supposed to make it simple to build on top of Azure. So build machine learning models on top of Azure using different data and so forth. So the idea of MLOps comes to mind when you're helping people build models on Azure, and a lot of the MLOps offering within Azure Machine Learning mirrors the ML Lifecycle tools within MLflow. So you see we have a registry to store and track data, models, metadata. We want to help you capture the lineage of what you're building, as well as use Git to track it, or GitHub Actions to run it. Manage and monitor these runs and make them reproducible, and also compare the experimentation that you've done. So with that, you kind of see this visualization of this loop, and MLflow covers most of the loop, right? Outside of maybe the editor, you have all of the package modeling, deploying a service, iterative experimentation. And the idea is, MLflow is an open source tool that allows you to do all of these things, and MLOps offerings within AzureML also are meant to do so. Can we have an open source client for actually interacting with these AzureML components? In order to do so, you need to look at what MLflow offers. So we looked at tracking actually when we were first starting out, before even the 1.0, and we saw, wow, this tracking stuff looks pretty interesting. Our run concept is actually pretty similar. Our experiment concept is pretty similar, and that'll allow us to integrate more easily. So we were able to integrate with tracking with the 1.0 release. MLflow projects is another one that we were able to look at. We had this idea of experiment.submit to send a remote job, where you have a snapshot of the current environment. All of that seemed to align pretty well with projects. The model concept is actually really well fleshed out within MLflow, and we're able to deploy those models within our system, but it used to have custom code for the deployment. Now you can actually have it automatically set up by MLflow. And then, tracking these models as you build them within MLflow seems pretty interesting. We had a similar model concept. Some of the tracking was different, but we were able to kind of start seeing how you might bridge the gap. Before bridging the gap, though, there's some pieces that you do as setup. So the VMs and stuff that you'll do within the workspace in Azure Machine Learning. And then for us, you can use MLflow to interact with those elements after the fact. So you can log, track, as well as interact with models, deploy models, and all your artifacts are stored. And at this point now, you can use MLflow for all of that within your AzureML workspace, which is pretty nice. So the idea here is, you have all these concepts. A pretty big subset of them can actually be showcased through MLflow and give a lot of that MLflow goodness around auto logging for free to our customers, and also allow our customers to use an open source client to interact with their code, since that seems to be where the industry is going. And we definitely want to make sure that they have the option. So why was this possible is a funny question to ask, but when I arrived, I came from MIT, where actually Matei was my TA in undergrad. And I finally, 2 years into AzureML, was wait a minute, why are our concepts so similar? And, doing some research, you find ModelDB. This paper that Matei helped write, actually showcased kind of how you might design a system to interact with experimentation and properly track it over time. And it's actually part of the base of the concept used for MLflow as well as AzureML. And that's why that you see so many similarities here, right? The model registry, the MLflow models, the projects all kind of align with some of the concepts that you're seeing here around MLOps within AzureML, and actually some of the concepts within AzureML beforehand. So with this obvious shared linkage, we're like, okay, how do we make this work? Right from the beginning, we saw this open source library. We try to, do an early integration, and we use our SDK at that point in time to do the integration. And we were able to get most of it working. Some of our early work was around making the ID schema within MLflow a little bit more open to different approaches. So it didn't have to be numeric, for example. So those were some of our early contributions to create alignment across the two systems. And then, after that, we ended up graduating our SDK-based plugin all the way to a full track service interacting with our components. So it's pretty nice to see how that progression went. And I'm kind of going to jump in a little bit into how we got started and kind of where we're at within this MLflow integration. So the workspace concept within Azure Machine Learning kind of alludes to the store concept within MLflow. So as you can see here, it's a pretty simple setup. Once you have a machine learning workspace and there's setup documents that we'll point to that you can use if you want to create one, you basically can get the tracking URI from us. And this tracking URI, we're not showing it here, but it's effectively the URL to our service with the HTTPS replaced with AzureML so that we know it's AzureML that you want to talk to. And that allows us to do some changes around tracking and artifacts and so forth. And after that, you set the experiment. That's the setup script. Everything else from here on out can actually be MLflow code. So you can track with MLflow code. This is an example we had where we translated one of our examples to MLflow, and it was actually almost line by line. It's really nice how almost nothing changed in terms of the actual logic, except you get a lot of benefits, right? The MLflow sklearn.log model just puts in a lot of extras information there that is really useful for deployments. And you can log an artifact as well, and it shows up in the UIs. Now, the concepts here, this on the left is the old script that you might have written, and on the right is the new script. This example may be exact translation. Yeah, it looks it. And you can see there's a run concept. The workspace concept's kind of all encompassing, kind of like the store. You don't really see it mentioned, but it's the underlying location. The experiment is also part of the run. And then after that, you can log. You can log a metric. And now you're using the MLflow client, but pointing to the AzureML service to back the interactions. And there's no change. And this is actually, even conceptually for our customers, there's really no change, which is really nice to see across the system. And it all comes to that model DB lineage from that paper in 2016. So this is sort of where we started. Initially client side, we just implemented the left side internally to our plugin. And now we have that service, as I mentioned. Cool. So we didn't stop there though. This is code running on your machine that you're able to run against MLflow backed by AzureML through that integration. You can also do remote code. So within AzureML, you were able to submit jobs, and the API is on the left here where you can kind of create an environment, create the kind of dependencies, and then submit a job. And on the left, you see the AzureML code. On the right is the actual training code that you would see in that script. Previously, it would have been that run.getContext piece, but this MLflow training code in the remote environment works pretty much the same. So you end up getting effectively the same submit code, switching out the data science code for MLflow, and it also works. But after doing so, we're like, hey, now we have to introduce developers to our environment object, our conda dependencies object, our script run config. Can we do better and only expose them to MLflow? And sure enough, we were able to do so. So here you can see this MLflow projects, and I'm actually going to go run it on the side now, but to just give you a little bit of context, you can see MLflow.projects run, which is sort of the way you submit a project to run, to create a run in MLflow, and you can parameterize it. But here we added backend support for AzureML. So now you can kind of think of it as an MLflow layer that internally will create all that script run config that you saw earlier and submit a job against AzureML. So now there's really only one concept here that we leaked from AzureML, which is a compute cluster. And that we can look at later, but let me go and show some of the demo code. So I'm hoping you can see my Jupyter notebook. This is running on a VM in Azure, but it could run pretty much anywhere. And we created a compute cluster of 0 to 2 nodes. So it's actually dynamic, so you're not paying for it when it's not running. And then you can, check the workspace out and kind of load it into memory, set the tracking URI to the MLflow tracking URI, and set the experiment here. And then same backend configuration we saw before. There's some setup scripts you can see within the AzureML setup code to just create a compute cluster. It's effectively a function call off the workspace plus some configuration points. And then you can submit a remote job. Through the AzureML project backend, it kind of showcases the output logging as projects. And we just kicked off this job at this URL. Now, the job itself is not completed yet. It's going to queue it up on our cluster that's dynamic. It's going to wait to create a new node. So in the meantime, I'm going to show you on the right-hand side an existing run. So here you can see that the run is completed. We can actually look at the code that was run. And then here you'll see that the train.py was run, right? You can see, all this code here. It was actually a different remote job, but you can see the log params, log metrics. You can see the RMSC was logged, as well as a mlflow.sklearn model. And you can see the backend configuration used. So this is sort of the snapshot of what was sent. And you can see the outputs. This is the AzureML UI pointing to the MLflow created runs within the AzureML setup. So here you have the ML model, the model.pickle, the conda YAML, kind of all the things you would see the script write. And you can even see the metrics too. You see 0.616 and so forth. So you kind of get all of the code you wrote with your open source client, and it's all logged to Azure Machine Learning with no extra setup on your side. And I'm gonna move over to the rest of the slides while this runs, since it has to queue up a whole new machine and so forth. So after we were able to get projects running, now you get to have reproducible code running on remote clusters using MLflow, remote clusters within AzureML. We were also looking into deployments. The deployments setup is not a plugin, however, yet. It's probably going to be at some point, given now MLflow has mlflow.deployments, but for now it's mlflow.azureml.deploy. And the basic idea is you get a model URI for an MLflow model, and you can actually pass that to this deployment function, and it'll create a service for you that you can then ping with requests for predictions, much like you do with the local service deployments in MLflow. And the idea here is we had some deployment concepts. You'll see the ACI web service above and web service and so forth. And we internally do the translation for you to then use those objects and create those objects. So you don't have to really fully understand how you would do this on top of Azure Machine Learning and Azure. One of the freebies we got, which didn't take extra work, was the MLflow UI. So given you have this end-to-end integration at the tracking store level, you can pass that same tracking URI to the backend as a backend store URI for MLflow UI, and it'll show up as well. So you can actually see these locally, which is pretty nice as well. Some of the comparison functionality within MLflow is amazing, and we end up having some customers come in and really look for that, and it's really nice that we're able to showcase some of it. Cool. So kind of gave a rundown of where we are now, I guess, or maybe where we were a few months ago, and what are we up to next, right? So as you can see, we've covered most of the integration points. The only caveat is there's this AzureML-MLflow library you install separately from the core SDK. And the goal for our team is how can we make it so that MLflow is such a small dependency with so much utility that we can actually move it into more environments by default. So it's easier for our customers to reach this MLflow code, as opposed to right now where they have to install this extra package. So the latest update for us is creating an MLflow SDK with a smaller footprint. Now, we call this mlflow-skinny. And the idea behind mlflow-skinny is we want fewer dependencies, a faster installation time, and a smaller environment. The idea here is MLflow-skinny is supposed to help optimize not just your deployments, right? If you can shave off the installation time on your deployments, that's actually pretty beneficial, but also the surface area between packages that are dependent on, because that's kind of a room for like issues across libraries. You know, you might have a package depend on some specific version of a library that MLflow uses for the MLflow UI, but if you're not trying to use the MLflow UI, for example, maybe in a remote job or in a deployment, maybe you shouldn't have that installation, and now you can run more code with MLflow and like capabilities, and that's sort of the goal that we were looking for, avoiding these NumPy type conflicts, as well as allowing for some scenarios that are a little bit more lightweight, so that they don't take all the dependencies of MLflow. I listed a few here. You can think of, you know, if you're trying to use MLflow to speak to SQLite, you would want MLflow-skinny plus the dependencies for the SQLite, for the SQL Alchemy store. For metric logging, you really only need MLflow-skinny. For tracking and model registration, you might need NumPys and pandas. You know, deployments, you need the models dependencies plus MLflow-skinny, maybe NumPys and pandas. But you don't really need, you know, you might need Flask if the service was built that way, but you don't need, I don't know, Docker in that remote environment, or possibly the SQLite, for example. And then for AzureML, this allows us to slim down to just MLflow-skinny, AzureML core, and that's it. You have the full functionality that we showed before without any of the extras. And then if our customers want the extras, they can add those extra libraries, or they can install MLflow directly. Both should work. How do we do this? So we ended up making 2 packages, but with the same code. This was actually Corey's idea, and I really like it because it's very clean in that, you know, there's a skinny requirements and there's core requirements. And what we ended up doing was shipping a library called MLflow-skinny with just the skinny requirements. And then the MLflow package is that same code with more defaults libraries. And those default libraries fill in gaps where now, instead of having that code work by default, there's sort of this optional dependency. So the idea that you would import inside the predict function, not 100% conventional, but it allows us to slim down the library quite a bit. And I'll showcase some of that later. And then, yeah, this change is pretty minimal, but it was cross-cutting. You had to pretty much understand all the libraries and kind of what was being imported where and how to like do the lazy load, and then verify it over time, because it touched every single aspect of the code base, but it was also pretty menial changes. So after we did these changes, before we did these changes, we kind of evaluated approaches. The approaches were this approach of lazy loading and kind of having sub packages. The issue with sub packages is because MLflow currently isn't set up that way, sub packages actually can cause quite a lot of changes in the development structure. So it was a pretty big overhead in terms of the dev cost for doing the sub packages, which is why we went with the skinny approach. The skinny approach is simpler to implement, right? There's like a setup.py conditional basically, and this lazy loading. Most of the issues that you would see with lazy loading can be fixed by having a strong build system, which MLflow has. So we were able to leverage that build system to evaluate all the components and make sure that we didn't, you know, leave something broken in the builds. And then we got the benefit of not having to change everyone's developer setup, which is, there's so many contributors within MLflow, it would be very difficult to do so. Some of the cons here, you know, installing the package MLflow and MLflow-skinny could be problematic. The setup of the Pi is a little bit more complicated. You actually have 2 builds to release 2 separate packages with the same setup of Pi, and you have some environment variables to configure it. It's a cost that comes with quite a lot of benefits, especially given what we'll show after. And then there is some education costs for users now, where if they install MLflow-skinny and there's a failure for the SQL Alchemy store, they're going to have to be educated on some of the dependencies of the SQL Alchemy store. These can be mitigated over time with certain like Python features, but for now there will be some costs of, hey, sorry, you need to install pandas and NumPy with MLflow-skinny, otherwise, you know, log model won't work. And that education will be a cost that's paid over time, in contrast to the developer overhaul that we would have had to do with the other approach. What were the results here? Before I get to these results, let's see the other results. Let's refresh here. Completed, same idea, pretty similar ROCs, outputs, models. So demo gods allowed us to continue. And we'll get back to the mlflow-skinny results. So, all right, let me kind of give a little bit of context. This top slide is saying if you install MLflow, what do you get? Well, your conda environment is about 305 megabytes. The import duration is, so import MLflow in your code takes 3 seconds. Installing, meaning like the pip install MLflow command takes about a minute, and pip freeze takes showcases 43 libraries. You add AzureML on top of that, and you get a conda environment of size 373 megabytes and 74 packages. The goal for us was to decrease that number, the conda size and the pip freeze size. So with MLflow-skinny, you actually get just bare bones MLflow-skinny, you get 109 megabytes, a third the size of MLflow, a third the duration, a fourth the install duration, and about less than half the packages. So there's quite a sizable decrease in the surface area and even increase in performance metrics for MLflow-skinny at the cost of, you know, the built-in features like the waitress-based store UI or some of the deployment features and Docker, for example, maybe even Kubernetes, things that you may or may not need, depending on your scenario. When you add AzureML Core on top of that, you end up with 202 megabytes, 56 packages, a pretty sizable benefit, almost half the size of what we previously had, and you know, about 20 packages less to interact with if there's any dependency conflict. In most scenarios, customers are going to want to use log models, so I also showcase the pandas side. And with pandas, you end up getting an extra 100 megabytes, and it kind of seems to be the cause of that slow import MLflow duration, and you save 20 seconds only on the install duration. So here you have it. We ended up getting probably around a 73 megabyte help, but in our remote environments, maybe a 202, almost like 170 megabyte help in our installation. But ideally, this would help other customers have easier remote deployments and in conflict with less environments. So it should allow for more flexible use of MLflow. For example, just SQLite plus your specific features, and ideally allow it to, you know, reach more environments easily. So with that, I'm gonna wrap up and open it up for questions. Yeah. Are there any questions? I'll move over to the Zoom call.
Well, thank you all. Thanks a lot, Eduardo. That was a brilliant demonstration of how skinny client used. I think one question that somebody posed was, under what scenarios would I actually use skinny client, and under what circumstances would I need the entire MLflow? I think you say the pros and cons, but could you repeat, under what scenarios would I use the skinny client by itself?
Yes, so the skinny client by itself allows for full plugin integration. So if your code was trying to interact with Azure Machine Learning for remote job submissions exclusively, you could use the skinny client with no extra dependencies and submit jobs to MLflow and with that log metrics and log models and so forth. So you could just use the skinny client plus the AzureML core library. So AzureML-MLflow will be depending on those. And you can do the full end-to-end experience of plugin integrations. We do have, so the auto logging comment interacts kind of funkily with some of the remote jobs. So that's partly why we haven't done it, but we're working with MLflow to see how we can effectively avoid creation of extra runs in parallel. But yeah, that's sort of the way you would look at the skinny client. Especially for deployments, I could see quite a sizable benefit because, you know, you don't really need the full UI setup in the remote deployment. So I expect over time we'll move the auto deployment code within MLflow to depend on the skinny client, and it'll have performance benefits in image creation and possibly even actual prediction times, because, well, not prediction, but setup times, so that init setup will be shorter.
So in other words, the MLflow, the use of MLflow's client is in conjunction with using AzureML, correct? You want to use it in conjunction with AzureML if you actually want to use the skinny client.
Yes, so our initial contribution is we want the AzureML integration to depend on the skinny client, And by doing so, we'll reduce the footprint of dependencies of the integration. And then we can start baking it in by default into more locations because we'll have to worry about fewer dependency conflicts. And that's sort of the reason. It's mostly client code, right? It's MLflow's client code plus AzureML's client code. And that just is easier to ship in more locations. Yeah.
Thank you. Do we actually have any other questions? I'm looking at some questions. There's what work would vendors who also provide their own metadata store and UI Neptune have to do to enable the Skinny client? In other words, if I wanted to use the Skinny client, can I actually use it with other vendors besides say AzureML?
Absolutely. So
I think they would actually have to figure out what yeah, go ahead.
There's nothing specific to AzureML here. If your integration with MLflow is through the plugin system, then you can move on to using mlflow-skinny. The only caveat here is if your code depends on some packages that used to come by default within MLflow, it might be broken. So then you would have to add those extra dependencies to your plugin. Alongside MLflow-skinny, it should reduce the footprint. But for example, if you use the MLflow UI internally, make sure to have those dependencies accordingly. So you can use it with any plugin really, as long as you make sure you keep the subset of functionality that you need for your integration.
Okay, thank you. I don't see any other more questions on the Q&A or on the YouTube or the LinkedIn. So with that, I think thanks a lot, Eduardo. And those of you actually interested to find out more about Skinny Client, we do have links in the YouTube channel, and we'll pass it around. So thanks a lot, Eduardo, and brilliant. Our next speaker is Daniel Rodriguez. Daniel is an ML engineer with Algorithmia, and as I said, Algorithmia is one of the companies that actually did integration with MLflow, and they provided a plugin architecture whereby you can use MLflow and then deploy the models on Algorithmia. So Daniel, take it away.
Thank you, Jules. So let me go ahead and share my screen here and move this guy here and start the presentation. So let me know if there's any issues with the slides or anything internally. So thank you, everybody. I'm going to be talking about Algorithmia and the MLflow integration that we did in the last couple of months. Who am I? My name is Daniel Rodriguez. I'm an applied ML engineer at Algorithmia. I have some social media links here. So on Twitter, I do a lot of like data science and ML ops type of things. I also review the latest Hispanic TV shows in Netflix and other streaming platforms. So if you're into that, definitely follow me. If you're only into data science and ML ops, also look at my website. I have a blog and different applications and open source plugins, open source libraries, and also my GitHub. I do a lot of other open source stuff around the PyData ecosystem, Jupyter, and so on. So what do I do? I work with customers to implement and integrate the Algorithmia platform into their infrastructure and processes and help them get their models in production and get value out of those. So Algorithmia's mission is to get models in production, get the models out of the development environment and put them in production. What does production mean? That usually depends a lot in the use case of the actual model. For us, production means you're getting basically money out of this particular model. Money is one way also to describe value. I like to say money because when we work with customers, they always open their eyes. But we want to get value out of the models. More specifically, that means we design data pipelines, monitoring and scaling of the models around Algorithmia, the Algorithmia Enterprise Platform, and the other infrastructure that customers have. We also spend a lot of time doing a lot of package management and environment management. Those are not as fancy as the other three bullet points, but there is also something that you have to deal with as you are developing, machine learning models. So we definitely do a lot of those things as well. The presentation is going to be relatively simple. What is Algorithmia? How do we integrate with MLflow? And a very simple demo of Algorithmia and the MLflow integration that we have built. So who is Algorithmia? We are still an early startup. We got started 7 years ago. I've been with the company for about 6 months. It's not been very long. there is some information here about Algorithmia. The most important thing to know for this presentation is we have a really big marketplace of machine learning models. If you go to algorithmia.com, we have a SaaS offering of our enterprise product where you can just sign up and start deploying your ML models, and we're going to see how that works in just a minute. We have more than 1,100 deployed models and more than 2,000 active users at any given time. So definitely check that out. We're going to see some demos about that in just a minute, like I said. Other than the SaaS platform, we worked a lot with enterprise customers. So these are some of our customers that we work with. You can see different verticals: insurance, telecommunications, consumer products, and other different customers that we deal that we have. And we, like I was saying, we help them get the models in production and get value out of those. What is actually Algorithmia? So it's an MLOps platform. It's an MLOps operations and management platform. We focus in the whole MLOps workflow. We focus on the deployment, like I said a couple of times, deployment, operation, and governance and security of those models. So deployment, we want to make really easy to get any model that any data scientist has out of their development environment and put it in production. We want to make very, very easy to manage the operations of those models, manage the cost, infrastructure, monitoring, and being sure that these models are scaling as they need, and all the different things around operations. So the platform helps you with all that. We also have a very focus. We also focus very heavily on the teams. Like in the teams concept, right? Like data scientists don't work alone, and you don't build these machine learning models and machine learning applications alone. So we help integrate the different teams and the different users of those teams into one cohesive platform. And around governance and security, it basically means knowing what's happening and who is doing what on the platform and with the model. So we enable we have logins and measurement around everything around the platform, so you can see what's happening at all times. How do we solve this problem? Our main objective is being able to integrate with everything that data scientists are using. That being all the different libraries, TensorFlow, Keras, PyTorch, MXNet, anything, any library that is being used. We want to be sure that we can support these models and we have environments optimized for all these different machine learning libraries. We also want to be sure that we integrate with all the different environments, so like Jupyter, VS Code, and all the other different platforms like MLflow. So we've seen a lot of MLflow usage in our customers, and that's why we decided to build this integration. So we want to be able to deploy any model based on any platform base. If you're building it in an Airflow pipeline or in a GitHub CI and CD, we integrate with absolutely everything, and we battle test all these different integrations, so we are sure that they work. And once we get it out, like I was saying, we be sure that the deployment is working fine, the operations are working as expected, and governance and security around the different models. So MLflow, like I was saying, we saw a lot of interest in our enterprise customers and users on our marketplace around MLflow. We start to see an increase of people asking to do better integration with MLflow around the deployment of the model that they train using MLflow. And we initially had like a couple of hacks and templates that we used to ship around, and eventually we decided to build like a real integration using the plugin system that it has. What do customers use or do with MLflow? These are a couple of bullet points here. They really like all the project management. It has a really nice standard project template for machine learning projects. The centralized UI is something that we see a lot in our enterprise customers. They have that as a experiment tracking, model registry, centralized UI, and centralized platform as well for all the things that are doing. So it's really a really nice platform for those type of things. I have the environment management part there because again, it's something that is not mentioned a lot. Eduardo mentioned it a little bit in his previous talk, but it's something that MLflow does very well. And it helps a lot our customers to do that. It's not very fancy, but it's something that it needs to be done in a very smart way. And finally, the model deployment, that's where our integration comes in. MLflow has this standard API to deploy the models that you have trained using their platform to really any service, right? So it could be Azure, it could be AWS, or in this case, it could be Algorithmia. So it really is a nice a standard way of or standard API to deploy models everywhere. It helps you with also like standardizing the actual REST API that you're going to be using to query these models. So it really has a lot of advantages around that, and that's what we see with our enterprise customers. Okay, so enough talking. Let's see how this looks actually in reality. So I wanted to do a super quick 1-2 minute demo of Algorithmia so people are familiar. So this is my account, the account that I have on the marketplace. So like I was saying, Algorithmia.com, we have hundreds and thousands of models deployed here. This is my particular account, and I want to show how an algorithm gets created here without MLflow, and then we'll see how MLflow automates all these different pieces. So if I wanted to create a new algorithm, I can just come here and name it my algo. And then I have the option to select the different environment that I want to have. So we support Python, R, Ruby, Rust, Conda as an environment management as well. So we support a lot of environments, a lot of languages, and in the environments we support and optimize different specific frameworks. So MXNet, TensorFlow, PyTorch. We also do a lot of work around GPU support. So we optimize all the different environments for each individual library, something that is really nice. There is 2 options to host your code. One is hosting it directly in Algorithmia, and the other one is to host it in GitHub. We also have support in the enterprise product for Bitbucket and GitLab. So this is something that a lot of people do, and I can just point it to a GitHub repo that I already have, and I'm going to show how that looks in just 1 second, how the code works. I'm not going to create a new one. I'm just going to show you one algorithm that I already created. This is one of my personal algorithms. It's called DMOX. DMOX is a machine learning model to do music source separation that it came out from Facebook research a while ago. Basically, you have an MP3 of a song, and it gives you 4 different files, one for the bass, one for the drums, one for others, and one for vocals. So I decided to wrap this into an Algorithmia a model, and the way that works is that I can just click on source code. I will send it to the GitHub repo that hosts this application. How this looks internally is very, very simple. So the way I like to explain this is that if you have used any other serverless service, being for example AWS Lambda or Azure Functions, or any Kubernetes framework that does that, Algorithmia works in a very similar way. So if I open the entry point, I will have the most important function, which is my apply function, and here I can just really do anything that I want in my particular model. I have some extra classes here to make things a little bit easier, but you can see I just imported the DMOX API, and I basically do an inference on the particular file. In this case, I have an input. In this case, this input is just the bytes that I upload from, or that I send using an HTTP request. And everything gets handled internally as I handle the file and pass it to the model. And what I do after in this particular model is that I upload the output MP3 files, the four independent ones, to the Algorithmia data store. So everything is integrated into this nice platform. What I decided to do after was to build just a simple application, a simple JavaScript application that uses Algorithmia to do the processing. So I'm not gonna run this. If you have any MP3 files that you wanna split, definitely go ahead and try the app. Once you have split something, it will give you like a really nice player here. And you can start actually downloading these files and do really whatever you want with the source separated files. So that's how it looks without MLflow. I had to do all this code. I had to think about the API. I had to think about the dependencies. I had to think about a lot of other things. With MLflow, as I was saying, it gives you this really nice standard way of doing different things. So what we decided to do was to, let me open the repository here for Algorithmia, MLflow, right here. So we decided to make an integration using the deployments feature of MLflow. So we decided to build this really simple Python library. You can just pip install this, MLflow Algorithmia. And what I wanted to do is just show a really simple demo of this running live. It uses the same MLflow tutorial that for scikit-learn that trains an elastic net. So really any MLflow model that you have, you will be able to deploy. There is nothing proprietary about the things that we do internally with the Algorithmia or the plugin. So I have this very, very simple setup for the MLflow project. So I have my project file. I use a conda environment to handle the dependencies. I have a couple of parameters here and just one train command. So very, very simple. In the environment YAML, I just have a couple of basic Python dependencies, pandas, numpy, and scikit-learn. MLflow, of course, to do the actual, to handle all the different things that it does. And in the train file, I just literally took it from the MLflow documentation. So again, any model that you have in MLflow will work exactly the same in Algorithmia. Nothing really changes. You can do all the regular MLflow things like having the parameters, logging the metrics. Everything will work exactly the same. So let's go ahead and run this really quickly here. So I will just do MLflow run that to train this particular model. This is going to run very fast. It's a very simple scikit-learn model, and I already created the environment before. So MLflow, as you guys probably know, caches this particular environment. So it created this super nice environment for me with just the dependencies for my project. What I can do next is actually serve this locally. So let me go ahead here in my notes and just copy this particular command here. So I'm going to do the MLflow's model serve command to serve this model locally. And all I need to do is pass the path to the model that I just trained. So once I train a model in MLflow, it will create it into the ML runs, the project ID, and then the run ID. And all I need to pass is the path to the artifact and to the model that it created. And I wanted to do actually the port 1234. It's exactly as it is in the MLflow documentation. So everything is exactly the same. It gives me a REST endpoint that I can use to query, and I can just here in a new terminal query that particular model. As you can see here, I'm just querying this locally 1234 and the invocations endpoint, and I pass the JSON, the pandas representation, the JSON representation of a pandas data frame. I'm able to query this locally. So everything works so fine. So how do I get out of the development environment into production, right? So what I can do is after pip installing MLflow Algorithmia, I can just do the MLflow deployments create command, right? So let me again copy this particular command here, and let's go super quickly here. So MLflow deployments is the new subcommand that they have done. We create a new algorithm and we use the type of Algorithmia. So this is the type that it gets added when you pip install our integration. And here I can just name the model that I want to create on the platform. I pass exactly the same path that I did when I was serving the model locally. So I just pass the path to the artifacts and the model. When I do this, a couple of things happen, and while we wait for this, I can explain this. What we do internally is we create a model in Algorithmia. We download that source code. We don't modify the source code to use this particular bundle that we create. So we also bundle the pickle file that MLflow creates in this case. Depending on your model, it will be a different file. So we bundle everything, we upload it to the data store in Algorithmia, and then the source code that we generate uses that particular bundle to serve the file. After that, what Algorithmia does internally is that it also builds a Docker container for you for that particular model. So if I go back to my account here and I refresh, I will probably see in my algorithm, this one wasn't here before. I have a backup, but this is the one that I just created, the MLflow_sklearn_demo. demo. And if I go to the builds, I'll probably see that this is building. So since I triggered the command, it's been 50 seconds, so it's building this particular container just for me. Just for the sake of time, I already did this before the presentation in another one, in another model that I created here for the backup. So this one is already finished. So it took 3 minutes to build. What this does is downloads a base environment, base Docker container. We install the other dependencies, and we, like I mentioned, we update the source code to actually be able to serve using the MLflow internal APIs. So what I can do after is go back here, and we have a lot of ways of querying these REST endpoints. So we have examples for Python, for Curl, and everything. So I'm just going to use Curl to query this particular model. Let me move this guy here and copy the Curl command here. The only thing that I need to do other than a regular curl command is export 2 environment variables, one with my username and one with my API key of Algorithmia, so I can actually have authenticated access to this model. So if I copy this command, you will see it's actually querying the Algorithmia API endpoint. Is using my username as an environment variable that I already exported, and for authentication, it's just using a simple API key as authentication. Then I'm actually just passing the
Daniel,
path
sorry
to
to
the.
interrupt.
Yep.
Can you zoom the terminal a little bit?
Zoom a little bit more. Yeah, totally. Yeah. Is that better? Is that a little better?
Yes.
Yep. Okay. Perfect.
Yes.
So
yes. Cool.
okay. So just go ahead again here quickly. We're querying the Algorithmia API endpoint, username, and pass and API key to be authenticated. One important thing here is that we're actually sending exactly the same JSON formatted pandas data frame. So everything is exactly the same as you would expect from the regular MLflow endpoint that we had running locally. So if I click, if I just enter and make this query, it's going to take a couple of seconds in the first time. We have in the marketplace, we have this concept of like warm and cold models. If a model is being called a lot, we have multiple replicas of this running concurrently, because this model is just for demo. It takes just a second to make the prediction. But what I wanted to show here is exactly the same API that you have from the MLflow log serving locally. And if for whatever reason you wanted to deploy this model to other platforms, you will be able to do exactly the same deploy command, and you have exactly the same API. So there is really no vendor locking that we want to do. And MLflow is a really nice platform to be sure of those type of things. So the result came back is exactly the same result that we saw locally, because it's exactly the same model. But what I do after is, for example, in MLflow is do a new experiment, but do a different parameter value. So I will train a new model. So I will do MLflow run again, and let me make this quick bigger as well. I will do MLflow run with a different parameter. This will train a new model. So it will give me a new directory in my ML runs 0. So now I have 2. The last one that it was trained is the B06. And what I can do with MLflow, because it's a really nice, it makes all these things really easy, is that I can just do the MLflow updates command. So I can do MLflow update deployments update, again, the type Algorithmia, and then the name, it will be the same that I had before, sklearn, MLflow sklearn demo, actually MLflow sklearn demo. And what I will pass is just the path to the new model that I created. So ML runs 0 and the path to the new one. So in this case, the B6, the B06 artifacts and model. So what this is going to do is in this case, it's not going to create a new model in Algorithmia, but it's just going to make a new bundle, update the source code to look at this new bundle instead of the previous one, and build a new container. So if I go back to the platform here and I go back to the one that we've been using here to demo, we will see that I have now 2 builds. The first one already finished, and now it's building a completely new independent container just for me. I can always go back in the platform and query the previous versions that I have. There's a lot of other functionality in the platform that I didn't show. For example, actually having named versions, so I can come back. I can come here and make a new version based on a build that I have created before. So we really handle all the life cycle of the deployment on the platform. Once this is done, I will be able to query this new model. It will be exactly the same experience. I will just change the command at the end. Instead of using this particular build ID, I'll just use the new build ID that Algorithmia gives me, in this case, this one, BEFE hash. So it will be exactly the same. So that's pretty much everything that I wanted to show. Really simple demo of both Algorithmia, MLflow, and the integration, how to get your models out of the development environment and into production. Next steps, just go to algorithmia.com and create an account, deploy any model that you have, and build like some cool applications. It's always nice to have also some free compute. So we offer like free compute for, there's a number of, there's a limit on this, but we offer free compute. So all these applications that I host, they're based on the free tier that we offer Algorithmia. So if you want to have that as well, it's always nice. install the MLflow algorithm integration, and if you have an MLflow model, be sure to deploy it to Algorithmia. And as always, let us know how this goes, and we're always happy to take any feedback. Okay, with that, I will take any questions if there are any.
Well, thank you, Daniel. I think this was a very demonstrative way of actually showing how you can actually take a model that you have developed locally, change the parameters, test it a little bit, and then use the MLflow algorithm or plugin to deploy it into your infrastructure. I think one question that actually comes to mind is that I noticed that you actually use the local ML runs URL to get the particular version of the model that you actually ran. Presumably, you can actually also register the model with the model registry and then get the staged version or the production version and then deploy that. And this will just create a new ID and a new container and a new image that's uploaded, correct?
That's correct.
With your
Yeah,
deployment.
that's totally right.
Okay.
Yeah.
Okay.
That's right. Mm-hmm.
Right. Yeah. So I mean, you're not only limited to just using the local version. You can actually register it to a central repository and then use different versions of those models deployed. And any one point, you can actually use the MLflow update algorithm to update that. That's brilliant. I think this was very, very demonstrative of how you actually use it. Let me see if we have any questions up. Kishore, will this publish? Yes, we're going to publish this. This is going to be published. The links are going to be published. And Daniel is going to share some of the slides with us and we'll upload that. Let's see, do we actually have any other Q&A questions? I don't see any questions. Do you see any questions on Karen?
I don't. Everyone has been very quiet today.
I know everyone is they're either completely mesmerized by both of you.
Yes.
So if you don't have any questions, I suppose we can probably end early. We just about time a little bit, but I just wanted to thank both Eduardo and Daniel for a great presentation, a great demonstration of how the community integrations and the community contributions have really extended the functionality of MLflow and how it actually works in the community. And I set the context earlier about why these meetups are actually important to amplify how the external ecosystem works with MLflow and how some of the community has actually grown. So I'm really grateful of that. I think we had some technical problems earlier, but we'll try to resolve that. But join us next week on the part 2 of this particular meetup, where we actually have 2 great speakers and 2 great integrations and contributions from PyCaret, which is a popular AutoML library that's really gaining a lot of momentum. And obviously, PyTorch is a huge contributor to integration with MLflow. So we'll actually hear about that next week. And with that, I want to thank both of you and hope to see you guys both at the Spark Plus AI Summit in a few weeks. And thanks a lot for your contributions and for your integration. We really appreciate it. And today you demonstrated why it's actually important to have that. Karen, do you have any closing thoughts?
No, I'll just say thanks again to Daniel and Eduardo. Great to have you. And I hope everyone who's joining us is also able to join us next Tuesday for our next session. So with that, we'll say hope everyone has a great rest of your day. Thanks so much.
All right. Thank you.
Bye.
Cheers.